guys, welcome back to my YouTube channel. Today I'm going to solve day 18 problem of this month on Leetcode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I'm going to solve problem number 1530, number of good leaf nodes pairs. Okay, so in this problem you are given the root of a binary tree and an integer distance. A pair of two different leaf nodes of a binary tree is said to be good if the length of the shortest path between them is less than or equal to distance. And in the end, we have to just return the number of good leaf node pairs in the tree. Okay, so this is example 1 given to us, and this is one root, and this is distance given to us. Okay, so what are the leaf nodes? Okay, so a leaf node is a node in which there is no child and no left child and no right child. Okay, that's it. So this is my leaf node because there is no left and right child. This is one leaf node, there is no left and right child. Okay, so now these two are only the leaf nodes are available to us. Okay, so now let's find the distance between them. So distance between them is nothing but, see here, I go one node up, so here 1, 2 and 3. Distance is 3 between them, right? And this distance is less than equal to this 3 given to us, right? So this is one good pair. Okay, so we have to just return the number of good pairs, so that is why my output is 1. Okay, so that's it for example number 1. Now move to example number 2 here. Okay, so in this example number 2, what are the leaf nodes? So 4 is my leaf node because there is no left and right child for this particular node. Same way 5 is a leaf node, 6 is a leaf node, and 7 is leaf node. So now you see that distance between 4 and 5, if you go one level up, so here 1 and 2, so distance between them here I'm checking for 4 and 5. Okay, so distance between them is 2, right? And this 2 is less than equal to d given to us, right? This one, so this is one good pair. Okay, now same way if you check for 6 and 7, both are leaf nodes, right? So distance between them is nothing but 2, right? So 6 and 7 I'm checking, so distance between them is nothing but 2, and this 2 is less than equal to d, so this is one more good pair. Okay, that's it. So now check the distance between 4 and 6. So if I go here 4 to 2, 1, 2 to 1, then 2, 1 to 3, 3, and 3 to 6, 4. Okay, so I am comparing between 4 and 6 now. So what is the distance that I'm getting? I'm getting a distance 4, and 4 is greater than the d value which is given to us, so this is not a good pair. Okay, so in this example you will find that only 4 and 5 and 6 and 7 are the good pairs. Okay, so good pairs are 4 and 5, 6 and 7 with the shortest path is equal to 2. The pair 4 6 is not good because the length of the shortest path between them is 4. Okay, so that's what we need to do. Okay, so now let's understand this example. Okay, so see here how I'm going to write the code. So initially my root is at this position. Okay, so initially this node is not equal to null, and this is also not my leaf node. So what I'm going to do, I'm going to move to the left side. Okay, so I move to this part. Okay, so now I am at this particular node, node 2, right? So here's I am going to check if my node is equal to null. No, it is not equal to null, and this is also my node, my leaf node, right? So what I'm going to do, I'm again going to move to the left. Okay, so now I reach at this position. Okay, so I'm going to check if my node is equal to null. So no, this is not equal to null. Now I'm going to check if left child of this node and right child of this node both are equal to null. Yes, both are equal to null. That simply means that this is my leaf node. That simply means that this is my leaf node, right? So now what I'm going to do here, since this is my leaf node, so my distance in this example 2 is given to us 3, right? Distance d value is given to us is equal to 3. So I am going to create one array. Okay, let's name that array as leaves. Okay, and in this leaves array I'm going to give the size as distance. Okay, so distance plus 1. Okay, so total 4 indexes that I'm going to create here, 0, 1, 2, and this index number 3. Okay, so total size I'm going to give as d plus 1, 4. Okay, so here this is nothing but my index number 0, this is nothing but index number 1, this is nothing but index number 2, and this is nothing but index number 3. Okay, so what I'm going to do, all these values are initially set to 0. Okay, initially all the values are set to 0. This is 0, this is 0, this is 0, this is 0. But here I am going to do one thing, I am going to update this one to 1. Okay, that simply means the distance of the leaf node from itself. Okay, 1. Okay, and I am going to return this to my node 2. Okay, so here I am going to return 0, 1, 0, and 0 to my leaf number 2. Okay, so this is what I'm going to do. Okay, same way I have to check in the right of this 2. Okay, I move to this right of 2. 5 is not null and 5 is a leaf node. Okay, both left and right of this 5 are null. So here I am going to create a new leaves array, and in this leaves array I am going to set the index number 1 to 1 because that is nothing but the distance of the leaf node from itself. Okay, so this is what I'm going to return here. So this condition is true now, right? So 0 1 0 0 from 2. Okay, now I'm looking from 2. Okay, so these are the distances, right? So distance 1 is 1. So that simply means that there is one leaf node at distance 1. So yes, 4 is one leaf node at distance 1 from this 2. In this 2 I am returning 0 1 0 from the right side. That is also true at this distance 1. Okay, because 1 is set to 1. At this distance 1 there is one node 5 which is my leaf node, right? So this is true, right? So this is what I am returning from both the sides. Okay, 0 1 0 0 and 0 1 0 0. Okay, so now at this node number 2 I'm going to check how many good count. I'm going to count the number of good pairs. So number of good pairs. Okay, so number of good pairs. For number of good pairs, this condition should be satisfied now. I plus j should be less than equal to distance. Okay, should be less than distance. Okay, I'm writing in short form d, and j should be less than equal to d minus I. Okay, so I hope that you guys are clear with this by I'm writing this. Okay, so I am going to run one loop. Okay, so this is nothing but my left side and this is nothing but my right side. Okay, I'm going to count the good pairs. Okay, I'm going to count the number of good pairs. Okay, so what I'm going to do, I'm going to run one loop. Okay, so initially my I is going to set from 1 and I is going to run for less than equal to my distance value is equal to 3. Okay, and then inside this, okay, I'm going to run one nested loop. Inside this my j is going to run for 1, starting from 1, and it is going to run until this condition d minus I. Okay, j is less than d minus I, j plus 1. Okay, so here what I'm going to find, I have to update my result. Okay, so I'm going to create one result variable, and in this result array, okay, let's say in the result of 0, okay, in this index I'm going to store the number of I'm going to get the final count. Okay, so here I'm going to see that when I'm going to multiply this 1 into 1. Okay, so just leave this point as of now. So just see that there are only one good pair, 4 and 5 at this node. Okay, so here I have updated my result of 0 as 1. Okay, that's it. I have updated my result of 0 as 1. Okay, because there is one good pair, 4 and 5 at this particular node. Okay, same way you guys will find that. Okay, so now from here what I have to return, from here I have to return something. Okay, from this 2 to 1 I am going to return something. So from here I am just going to return 0 0, and here I am going to write 2 and then 0. Okay, so this condition is also satisfied, right? At distance 2 is 2, that simply means that there is a there are leaf nodes which are available at distance 2. Okay, so 1 2 1 2. Okay, so 2 leaf nodes are there at distance 2. Okay, that is why I have set it to 2. Okay, same way I have to return from this part. Okay, same way your guys are going to go to this node, then your guys are going to get this node, then you will check left and right, you will find that this is my leaf node. So from here you are going to return again same thing, 0 1 0 0. Again from here you are going to reach to this position, from here you are going to return. Okay, so you are going to get 0 1 0 0. Then for this 3 you guys will find that there is one good pair, 6 and 7. Okay, so you are going to just update this result, okay, to 2. Okay, so this is what we did here, and from here I am going to just return 0 0 2 0. Okay, so now from here you will see that the distance between the leaf nodes at this particular point. Okay, if from 1 I am taking. Okay, so you will find that 4 1 4 to 2 1, then here 2 3 4 4 is a distance. Okay, so this is not true, right? We need a distance less than equal to 3. Okay, so I am just going to return my final result. Okay, this 2. Okay, that's what we need to do. Now I'm going to write the code. Okay, and with code you guys will get more clear understanding of what is happening here. So first thing that we have to check here is that if my root is equal to null, then in that case I'm simply going to return 0. Okay, then after that I'm going to create one result array, and the size of result array is just 1. New int, here I'm just going to write 1, and then after that I'm going to call one DFS method, and in this DFS method I'm going to pass my root, I'm going to pass the distance, and then I am going to pass the result. Okay, and I am going to expect that this method is going to return me the result. Okay, so here I'm just going to return, and the result array at this position I'm going to get the result. Okay, result of 0, because my result array size is just 1. Okay, so 0 index only I have to return. So now let's create this method. So private int array type, and here I am going to write this method DFS, and inside this I am just going to pass my node, tree node, and here after that just pass the distance, and we have to just pass the array, okay, int the result array. Okay, so inside this I am going to have to check if my node in the starting is equal to null. Then in that case I have to simply return, okay, if my node is equal to null, then in that case we have to simply return, and here I'm just going to create a new array, right, new int, and in this I'm just going to pass distance plus 1. Okay, that's it. So here I'm going to write distance plus 1. Okay, so now let me write the condition for the leaf node. Okay, so if both left and right child of this node is equal to null, okay, so if node dot left is equal to null and node dot right is equal to null, then in that case we have to create one leaves array. So, okay, that's what we are doing here, right? So what I'm going to do, I'm going to create one leaves array, and I have already told you that we are going to give the size as distance plus 1, right? So that's what I'm going to do here, distance plus 1, and then after that I have told you that I'm going to set leaves of 1 is equal to 1. And why I'm doing this? Because a leaf node is at distance 1 from itself, okay, and whenever I'm returning, see here, 0 1 0 0 at to this to node 2, then I'm going to get the correct result at distance 1 there is one node, one leaf node. Okay, so that's what I'm doing. Okay, that's what, so that's it. Then from here I'm just going to return now. So after updating this, I am returning what? I am returning just leaves. Okay, this is what I am returning here. See, I am returning 0 1 0 0 to this part, na 0 1 0 0 to this 2. Okay, this is what I am doing. That's it. So I hope this is clear. And every time I am moving first left and then I am moving to the right. Okay, so if I am moving right, then I am going to get let's create one array. Okay, here for get the left leaves, and to get the left leaves I'm just going to get again call this method DFS, and in this DFS method I'm passing node dot left, and distance is going to same, and I'm going to pass the result. Okay, that's it. Now if I'm moving to the right side, then again I have to call this method right leaves, and here I'm going to call the method DFS, and now I'm just going to pass node dot right, distance here, and result here. Okay, that's it. So this is done, and the right spelling is again wrong, so RIGHT. Okay, this is done. Then after that we have to count good leaf pairs. Okay, good count leaf pairs. Okay, so here I am updating a result of 0 as 1. Okay, for this 2, then for this 3 I have to update. So how we are doing that part? Okay, so for that I am going to run one loop. Okay, and I've already explained these conditions. Okay, so I'm going to run one loop for int I is equal to 1 starting from 1. Okay, I is less than equal to distance and I plus plus, and j loop for right leaves int j is equal to 1, and I have told you that my j should be less than equal to distance minus of I j plus plus. Okay, and here I am just going to update my result of 0 value as result of 0 plus left leaves of I into right leaves of j. Okay, so you will find that I'm going to get the answer as 1. Okay, by just using this one. Okay, these conditions. Okay, so now after calculating the good leaf pairs, then after that we have to combine the distances. Okay, and combining the distance simply means that I am going to return this 0 0 2 0 here. Okay, so what I'm doing here, so I'm going to create one new leaves array. Okay, because we have to return something from this 2 to back to 1. Okay, we have to return the combined result of this to this one. Okay, that's what we need to do. So int leaves is equal to, again create a new array, new int distance plus 1, and here after that I'm just going to run one loop, and I is equal to 1 and I should be less than distance. Okay, and here I plus plus. Okay, so all these things we have to update. Okay, so here for this particular part I am just going to modify leaves of I plus 1. I'm just going to update leaves of I plus 1 is equal to left leaves of I plus right leaves of I. Okay, this is what we need to do. So left leaves of I plus right leaves of I. Okay, this is true now. So since I am moving one step more up, so definitely distance 2 is going to be updated as sum of previous 2, right? So this is what we need to do. Okay, that's it. Every distance moving up one by one. Okay, so I have updated this. Then in the end we have to just return the leaves. Okay, return leaves. That's it. Now let's try to run the code and see if there are any code issues. Then we will try to fix them. So the test cases has been accepted. Now let's submit it. So see, our solution is accepted, right? And it beats 100% of users with Java, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.